Okay, in this section of our guided notes, 1.3 is called Displaying and Describing Categorical Data. This has to do with Chapter 2. So as you see here, the most important first step is to always make a picture. So you'll have some visuals here on the bar graphs and pie charts. And these displays work with categories, with categorical data. So to fill in the gaps here, this displays the category name, so frequency tables. The first one here is a frequency table. It displays the category name and counts, so like tallies, like if you were to tally the number of data values in each category. Example number 1, which of the following was your favorite toy as a child? So say we collect some data, and right here you see the name of the category, so or the name of the toy: Barbies, Legos, Ninja Turtles, video games. This is play dress up. And say we have a frequency that 8 students chose Barbies, 9 chose Legos, and so on. If you add up all these numbers, you should get the total amount of students in the survey. So in this case, there was 29. Relative frequency. To get the relative frequency, you're going to have to divide each of these numbers by the total. So here's an example: 8 over 29. Then it'll be 9 divided by 29, 2 divided by 29, and so on. And you get some decimals. However, when with relative frequency, you could display them as a decimal or as a percent. So 0.276 as a percent, you just move the decimal place over twice, and it becomes 27.6%. You do that for all the decimals, and you get the percentages. If you add up all the percentages, you should get 100%, the whole, the entire, take into account all the 29 students involved. Something additional here is called cumulative frequency. So cumulative frequency has to do with adding these percentages. So we start off with the first initial percentage, which is 27.6%. And cumulative means you keep adding them up as you go. So you're going to take 27.6, add it with 31. That will be 58.6%. You want the next one, you're going to take 58 and add 6.9 to it. Use your calculator for that. That should be 65.5%. Add 65 with the next, with the video games. That should be 93.1. And if you add this with dress up, it'll be 100%. Okay, so that's a cumulative frequency. Now, the bar graph, to create a bar graph, you must know that bars in bar graphs, bars do not touch. It's okay to have these gaps in between the bars. This is the case is differently for histograms when we get to histograms. But for right now, bar graphs do not touch. The height of each bar represents the count for the category. So for example, I'm gonna draw my y and x axis here, and from here we start off at 0 and go all the way to 10, since the highest number here is 9. So going up to 10 is good. And B represents Barbies, Legos, Ninja Turtles, video games, and dress up. So I'm gonna put the count. It's a good It's good practice to put the little number at the top as well. So like this is 8, this is 9, 2, 8, and 2. If you add up all of them, they should equal exactly 29. Some other important information here. Remember to label, put a title. What kind of bar graph is this? This is a bar graph for favorite toy, as well as the pie chart. Here you're labeling the axis, which is frequency, which is the count. So here's the frequency and the type of the toy. So I'm labeling the axis. And for pie chart, you want to make sure you include all the categories to make it complete. Okay, so that's all the categories for this pie chart. And it does matter the size that you draw it. So you see that N and D, like Ninja Turtle and Dress Up, are the smaller percentages, like 6.9, 6.9. That's this one and this one. And our largest one is Legos at 31. So that's why this section of the pie chart looks bigger. Next is two-way tables. So let's spend some time here on the two-way tables. Here is some data that you're going to need for two-way tables, and I'm gonna write it right here. So let's fill this out. This is going to be 1, 5, 2, 5, 0. These numbers are, if we were to collect these numbers by in class, and we were to survey certain students, this is what we would get. So for our purpose, we already have the data here, and we're going to use this to complete our assignment. Okay, so something that is not given here that is very important is to add up all the columns. So right here, you will see that you got 13, 16, 8, 9. This is 2, 5, and 3 is 8, and 0 plus 2 is 2. And they should add up to the total number of students involved, which was 29. Okay, so for the two-way table, you have question number 1, the number of students who chose Ninja Turtles, question number 2, question number 3, and question number 4. Okay, so let's start off with the first question. We want to find the percent of students who chose Ninja Turtles. So we want to find the percent of students who chose Ninja Turtles. So let's see, Ninja Turtles is right here. Let me use okay. So for Ninja Turtles, we want to find that percentage. This is an example of marginal relative frequency. Okay, so the word marginal, think of what's in the margins outside. Okay, this has to do with the blue numbers, not the red numbers. So the number of Ninja Turtles in total, there was 2. And if I'm looking for the percent, I need to divide that by the total amount of students involved, and that would be approximately 6.9%. Next is number 2, the percent of students who are male and chose Ninja Turtles. This is an example of joint relative frequency. So under joint relative frequency, it's talking about the numbers inside. Okay, the numbers inside. So let's see, the number of students who are male. Okay, here's the section for male. And I'm looking the ones that chose Ninja Turtles. So that's this one right here. So I'm using this number 2 divided by the total of students. So this is once again is 6.9%. However, we got this answer differently from this one. Number 1 was looking at the margin on the outside, and number 2 was looking at the inside numbers with this 2. And number 3, this is considered a conditional relative frequency. It is considered a conditional relative frequency because it is sometimes in the question it'll say given that that will be the keyword given. In this example they don't use it, but that's a key word when working with conditional. So number 3 says the percent of females who chose Legos. So we look at the percent of females. Here's the percent of females. And we know that there's 16 females. So this is going to be out of 16, not out of 29, because we want to look at the percent of females. On this one, on number 2, they said the percent of students who are male. So since it says percent of students, that's why we have 29. But on this one, it says percent of females. So that would be 16. 16 females. And I'm looking for the ones that chose Legos. That's 4. So 4 out of 16. That's about 25%. Okay. And finally, number 4, how many variables does the table have? And what type? It has 2 variables, which are categorical. Okay, as mentioned in the beginning, we're working with categorical variables. Barbies are category, and the gender is a category. Okay, here in this blank, we're gonna go that gender predicts the toy selection or the toy choice. And we also want to know that the gender is considered your explanatory variable. Gender is your explanatory variable, and this is your response. Okay, so knowing the gender will predict what the toy selection. Okay, now for segmented bar graphs. So segmented bar graphs are similar to the pie charts. So this displays the same info as a pie chart, but now with bars. So instead of a circle, now is bars stacked up on top of each other, and it depends on the sizes still matter. So the larger percentages would get a larger space, and here we label the label and title. and the key. So label the axis, title it, and here is what these numbers represent. So for males, we have a bar graph for males, or a segmented bar graph. So the way you would do it is, for Barbie, you would go from 0 to 0.77. So you, from there to there, it is 0.77. And then for Legos, these numbers come from above, from the top problem. Then you would just stack these up on top of each other until they add up to 100%. So from here to here is 100%, or if you're using relative frequency with decimals, so instead of 100%, it is one whole, from 0 to 1. Okay, you can't get past 1. And then there's the same thing for female and their percentages from these right here. Okay, this is an important topic in statistics, association. Is there an association between gender and type of toy? So if you compare both pictures, and notice that the pictures look different, they're not the same amount. For example, for Legos, you don't have the same amount for males than for females. So an answer here is yes, there is an association. Knowing the gender, male or female, changes the percent of toy chosen. For example, 43.8% of females chose Barbies compared to only 7.7% of males. So that means that since these are different numbers, there is an association. Okay. At the same time, if there is no association, what would the graphs look like? If we say that there's an association, then you would have the graphs to have looked the same for male and female. So for example, um, say this is the graph for males, and say this is the graph for females. If they look identical like that, then you would say that there is no association. Knowing the student's gender would play no role in knowing the toy choice. Okay, so if similar pictures or segmented bar graphs, then no association. In this topic of mosaic plots, here we have a question says, a new principal decided to have students and teachers vote between three choices for a school mascot. There was the ram, falcon, and the prairie dog. He took a random sample of students and a random sample of teachers. The results were given in this table. So here you see that the rams for teachers, 80% of teachers chose ram, and while 30% of students chose the ram. You should know that if you add all these up, they should equal to 100% of the teachers voting. 30, 60, that's 90 plus 10%. That's 100%. Also, we see here that it says create two bar graphs below to display the results. Use different colors for the bars. Complete the third graph by taking each bar from the teacher sample and stacking them. Use colors to mark each section. Do the same for the sample. Oh, I do gotta share that for teachers, there was 100 teachers surveyed, and for students, there was 500. So here is the plot that we're looking for. Here's the plot. Let me fix this. All right. So this is what we're looking at. For teachers, you have the relative frequency from 0 to 100. And here you see, let me see. Right here, I'm labeling I have my labels, I have the title. Here's the RAM. The RAM goes all the way to 80%. The Falcon goes all the way to 10. And the same thing for this one, for the Prairie Dog. 80, 10, 10. And for the student is 30, 60, 10. All right. So that was the easy part. These are just your regular bar graphs that you've done, and you're allowed to have spaces in between them. Now, this is a segmented bar graph. This right here is an example of a segmented bar graph, just like we did at the top, where you stack them up on top of each other. So for teachers, that blue color belongs to the RAM. So that's all the way up to 80. And then you have 10 and 10. So that the max is 100%. Okay, so this is aligned with 100%. We do that. We do the same thing for students. So this is 30, 60, and 10. I'll come back to this, what this represents and where this comes from in a little bit. Okay, but this would be enough for the first question. Question number 2, according to the displays, which mascot appears to have the most support? So it looks like the RAM. So a possible answer, you could say the RAM. If you stack the bars for RAMs together for teachers and students, it would be the tallest. So if you were to measure the 80 and the 30, these would be the tallest bars. So from this, it looks like um, the RAMs would be the most popular vote. Okay, and then for number 3, the students argue that the decision was incorrect because 100 teachers had been surveyed and 500 students had been surveyed. Use this information to fill in the table below. So we're going to fill out this table. If we convert this into, let's see, we convert this into numbers here. This is what you're going to get. Okay, this is what the table would look like. So the way we get these numbers is if there are 100 teachers and 80% of them chose RAM, that means that 80 of them, so 100%, 100 teachers times 0.80, that would be 80 teachers. Same thing for Falcons, 10 and then 10. This 150 is the same idea, but we have 500 students, right? So it's 500 students times 30% of them from the top information. There was 30% of students that chose the RAM. So if you multiply this, you'll get 150. So 30% of 500 is 150 students. Then you get 300 students, which is 60% of 500. 10% of 500 is 50. And you see how you fill those out. And then if you add them, 80 plus 150 is 230. Add this, and you should get the total amount of people involved in this in this voting, which was 100 plus 500, that's 600. Okay, how many times, how many more times students were sampled than teachers? So right here we see that there is times five. Students were sampled 5 times more than teachers. How can we update the third graph in number one to take into account the sample size? Well, then we would have to add uh, 5 of these in total. So right here you would have one segmented bar graph for the teachers, and then you would have 5 for one, two, three, four. You would use the same colors. Then you would have 5 for the students. And this is what we call a mosaic plot. This is a new topic in AP statistics. And now you see, instead of just stacking the blue graphs and saying that the Rams had more votes, now we take into account all the 500 students. We see that the majority of students chose the Falcon. Right. So number 5, what should they make the mascot? So the Falcon was the got the more people who chose Falcons, 310, and the other ones were than the other mascots. So we would see that 310. The Rams got a total of 230, the Falcon got 310, and the Prairie Dogs got 60. So they should make it the Falcons because it has 310 votes.